Volcanoes are scary. They can level cities and disrupt the entire global climate system. And if that weren't bad enough, a new study says they might also be the reason for future pandemics. Yikes. Of course, it's not the volcanoes themselves that are the problem. It's what they spit out. When a volcano erupts, it ejects rock, ash, and gases into the air. This material makes its way into our lower atmosphere, which is a soup of different chemical compounds, including water vapor, oxygen, and a whole bunch of other stuff. But there's one ingredient that can't be found in our atmosphere: microbes. And yet somehow these tiny organisms seem to hitch a ride on every volcanic eruption. In fact, we know this because scientists have actually collected samples from the air during eruptions. Back in 1991, Mount Pinatubo in the Philippines erupted so violently that it was visible from space. And 2 years later, scientists analyzed ice cores extracted from the Greenland ice sheet to see how the eruption affected the northern hemisphere's atmosphere. They discovered bacteria, fungi, and even viruses floating more than 40 kilometers above Earth's surface, all thanks to the plume of debris shot out by the volcano. And this isn't unique to Mount Pinatubo. In 2021, researchers analyzed another ice core from the Law Dome in Antarctica and found biological material from an eruption of Mount Ibu in Indonesia that happened more than 30 years earlier. And there's one microbe in particular that's seemingly ubiquitous in these volcanic plumes, a type of fungus called Eurotium. These hardy little guys are everywhere, hanging out on stuff like soil, rocks, and even paper. And they tend to prefer environments with a lot of sulfur dioxide, which is also a common volcanic gas. So it makes sense that they'd be the perfect organism to hitchhike on a volcano. And while scientists have known about Eurotium's love for sulfur dioxide since the 80s, they didn't realize it was a prolonged journey until recently. See, those microbes don't actually get blasted into the air by the eruption itself. Instead, they prefer to wait until the eruption is over. And then they get carried aloft by wind currents riding in on a cooling wave of sulfur dioxide gas. And when they arrive at their destination, they're not alone. Along with these fungi, volcanic plumes contain bacteria, viruses, organic matter, and even pollen. This mix of stuff forms a sort of microbial cloud that spreads far and wide from the volcano. And while this might seem like a one-way trip to parts unknown, scientists think some microbes can survive in these clouds for months, maybe even years. They might be tucked away in tiny water droplets or just chilling inside solid particles of debris. And once they land, they can stick around for a while. For example, microbes in the Mount Pinatubo plume were still detectable 5 years after the eruption. And microbes from a 2010 eruption in Iceland persisted for at least 3 months. And all this time, these microbes are happily floating along, surviving at high altitudes, enduring extreme cold, and even withstanding massive changes in air pressure. To figure out how they do it, scientists are turning to the only place they know of that has anything even slightly resembling these conditions: outer space. See, up in the upper atmosphere, it's really cold, reaching as low as -100 degrees Celsius. And at those frigid temps, most liquid water will freeze, which means any microbes living in the upper atmosphere need to be able to survive without water in its liquid form. And space is also really dry, so any microbe hoping to live there needs to be able to deal with dehydration. Now, life as we know it wouldn't be possible without liquid water, but some microbes, including certain types of bacteria and fungi, can go into a state called cryptobiosis, where they basically pause their biological functions until they rehydrate. As for how long they can stay like that, well, it depends. One group of cryptobiotic bacteria managed to survive 240 days without water, while another group was brought back to life after being dried out for 160 years. So when you're talking about cryptobiosis, your guess is as good as anyone else's. And while we don't exactly know how these microbes survive in the harsh environment of the upper atmosphere, we do know that they're capable of it. In 2017, researchers found cryptobiotic bacteria in a place we would never expect, the Tibetan Plateau. Here, the thin air and intense UV radiation closely resembles the conditions in the upper atmosphere, and yet life still manages to thrive. And when researchers exposed these bacteria to conditions mimicking the upper atmosphere, they found that many of them survived. So when it comes to microbes hitching rides on volcanic eruptions, it seems that nothing is out of the question. But why? Why do they do it? Well, part of the reason is probably the same one that drives any traveler to pack light. The journey is hard enough as it is, so why bring along everything but the kitchen sink? By shedding most of their mass, these microbes are able to spend less energy maintaining their bodies and have more resources left over for finding new food sources. And while shedding most of their mass sounds kind of scary, this isn't like shedding pounds. These microbes aren't losing anything essential. It's more like shedding a coat. Once they find somewhere warm to land, they can just pick up where they left off. And when these intrepid travelers finally reach their destination, they might find that conditions are already primed for their arrival. Volcanic ash can make an area temporarily more hospitable for microbes by providing nutrients that would otherwise be unavailable. Take iron, for example. Normally, it's only accessible in rocks, but when it's blasted into the atmosphere and deposited on land, it becomes available for microbes to use. And with access to new resources, some species are able to grow faster than others, kickstarting an ecosystem almost from nothing. Not only does this mean that the first microbes to arrive at a newly erupted area have an opportunity to grow and reproduce before any competitors show up, but it also gives them a chance to become invasive. For example, after Mount St. Helens erupted in 1980, a species of cryptobiotic bacteria found its way to the blast zone and thrived there for years. Scientists think the species was already adapted to survive in harsh environments, thanks to its life in the upper atmosphere. So when it arrived at Mount St. Helens, it had a leg up on the competition and took full advantage of its new surroundings. And while this might sound like a bad thing, keep in mind that life needs a little kickstart after a volcanic eruption. Without those hardy pioneers, it could take years before the ecosystem recovers. And speaking of recovery, remember that volcanic eruptions also happen underwater. And in these cases, the microbes in the eruption plume can kickstart life in the surrounding ocean too. For example, a team of researchers explored an underwater volcano near Italy and found an entire ecosystem supported by microbes that likely arrived via volcanic plumes. And these systems are unique because they're basically self-contained, with nutrients provided by the volcano and sunlight powering photosynthesis by microbes and other organisms. These ecosystems don't rely on outside sources of energy or nutrients. But here's the thing, while these self-sustaining ecosystems are neat from a scientific perspective, they're not necessarily resistant to change. A nearby volcanic eruption or shift in the local current can completely change the environment and wipe out the existing ecosystem. And while these systems can bounce back, it takes time. Plus, there's no guarantee that the species that rebuilds it will be the same ones that lived there before. So volcanic plumes are like tiny time machines, carrying microbes from the past and depositing them in the future. We might not be able to predict exactly what these microbes will do once they arrive, but we do know that they'll be survivors. And while it's fun to imagine hardy little fungi taking a vacation to the upper atmosphere, it's also worth remembering that these microbes play an important role in our world. Some of them help us break down harmful substances, while others are crucial for growing crops. And though it might be a little unnerving to know that these little guys are making trips through the air, we should also feel grateful for their ability to thrive wherever they go. If you enjoyed this episode and want to learn more about how the world works, you can keep watching this channel.